slides had the Android on it, so I just wanted to mention that as I was going through it. So we have this new portable solution that's just, the big focus is on ease of use, so that the users can just, draw a polygon, say that's what I want, download it to their notebook computer, double click, and off they go. We have a new support portal for our enterprise customers. So if you're currently an enterprise customer, you might be frustrated a little bit by, just the email. So, we're having a new support portal. And things that are going to be coming out soon, Google Earth 4.0, which does the portable really well. That's going to be coming out in about a month. And then the new client. We're going to have a new Google Earth client that's coming out, and it will have a bunch of new features, one of which is if you drag and drop a really big KML file into the client, it won't die. It will actually take that file, break it up, parse it out, and make it so that all the data doesn't try to come on all at once. It will only come on as you zoom down. Once you get into a region, the information will start displaying. And with that, I have 10 minutes, which is pretty good, because I always want to leave at least 10 minutes just for questions having to do with anything Google, geospatial, or even just geospatial. What kinds of things have I seen in the field, or really any kind of questions at all that you might have about Google products, or just some of the the geospatial things that are happening today. So we have one here. Right. Right. So the 5 gig file that we downloaded, so this is that portable that I just brought up. And so these are your layers here. I mean, National Park Service, USGS, so any layers that you have built into your globe, as soon as you draw that polygon, the terrain gets picked up, the imagery gets picked up, all of the layers. If your layers are searchable, we have ways of making layers searchable. The search information will also get picked up. So you get the entire Google Earth experience for that polygon area that you drew. Right, so this is our enterprise solution. Can you add to the layers? On the enterprise solution, you have 100% total control over the globe. You add layers, you remove layers, you add more imagery, you take imagery away. So it's yes. So you can update it as frequently as you want, as infrequently as you want. One of the questions we get all the time is, why haven't you updated my globe? Why haven't you updated my house? The imagery is 3 years old. But if you have your own enterprise server, you can update as often as you want. If you're getting updates every month, you can just keep adding and adding and adding and updating the information on your globe. Oddly enough, it's kind of a paradox. The better your data is, the more often you have to update it. If you have 15-meter imagery of your neighborhood, you can identify your neighborhood, but you can't really identify your house. 10 years later, it's still going to look the same. Unless a whole new neighborhood is built. But if you can come all the way down and identify which car is in your driveway and notice that your kid's school still has those temporary trailers out there, and then you're like, wow, this is old. This needs to be updated, Same thing with vector layers. If you have really high quality vector layers, the stuff changes pretty quickly, so you really have to, keep on top of it. And, I think vectors are the hard ones. Imagery, plane flies over, takes some pictures. Imagery takes hard disk space and CPU time. But what really takes people's time is the vector data, trying to keep that up to date. Have we added a new school? Has, the phone number changed? All that kind of stuff. I mean, that really takes a lot of time. And, Google's stated mission is to organize the world's information and make it universally accessible and useful. Our mission is not to create the world's information. Okay, and that's where you need to have a database administrator. You need to have your ESRI, GIS professionals who are creating layers, updating them, maintaining them, version control, all that sort of thing. And then once it looks, once it's ready, Google will help publish it and show it to the users. But you still need to maintain your own back-end database, and Google can't really help you with that. Yeah, about here.
Good morning, Mike. Thank you very much. In today's increased interest in place-based reporting, you mentioned data quality. We all know data quality is key. Can you explain Google's process for geocoding?
Wow, our process for geocoding. Yes, I mean, I can take a stab at it.
Okay. Or that levels and those layers, you know.
Yeah, so with geocoding, if you ask Google, where's 123 Main Street, Anytown, USA, you'll get back an answer. And the answer will usually have a quality associated with it. So lowest quality is like, well, we know where USA is, you know, so here's the United States. Or we know where Anytown, USA is, or we kind of know where Main Street is. A lot of our geocoding was purchased, especially still in Europe. We get things from TeleAtlas, and you'll see it at the bottom. You know, when you go into Google Earth, you'll see at the bottom all of the different, you know, partners that we get our data from. So a lot of our geocoding, you know, basically just goes to a third party. Recently, Google has obtained its own data set. In the United States and Canada are released, I believe. The United States is definitely released. I think Canada is released, where we have our own data set from the Street View cars. Well, you know, we start with the census data that has the basic road information. Then we have the Street View cars that are driving constantly with GPS and wheel calculators and inertial navigation. So we're getting our own road data, and then we're asking the users to update. So if you think your house isn't really where it is, you can move it. And, you know, based on all those different inputs, we think we have a pretty good idea of the quality of each one of the answers. So if I have gone into Google and said, no, my house is actually right here, that's, you know, pretty good quality. If I just go to 123 Main Street, sometimes they just interpolate. Oh, here's Main Street, 123 is a quarter of the way in, so here it is. And that's not really rooftop geocoding, that's more interpolated. Or there's, you know, places in the world where they don't really even have addresses. You know, it's like, go 100 meters past the Red Cross, turn right, and look at the greenhouse on the left. I mean, so you wouldn't get a very good quality. I mean, is that kind of, was there something more specific?
Well, that's the layers I was looking at, that rooftop, you know, and then
right.
level, zip, you know.
Yeah, and Google gets its data from all over the place. A lot of states and government, you know, donate their data to Google. NAPE from USDA is a huge imagery data set. The Census Bureau puts out a whole bunch of data. Individual cities and towns share their rooftop geocoding with Google. So, you know, it really depends upon where we got the data from and how, you know, what the quality is, dictates what kind of an answer we give back.
Well, Mike, what are your plans for elevation maps? I can see there, you know, the stream gauges, because USGS has this massive effort on 3D, that is map of the United States for flood prevention, et cetera, et cetera.
Right, so we have two types of 3D. One is with Google Earth, where you're literally tilting it, you can see the 3D. The other 3D is if you go to Google Maps, we actually have a terrain map that is a shaded relief, basically. You know, I think the idea with terrain is the same as with imagery. We'll take whatever data we can get our hands on from whoever will give it to us. We recently introduced Google Ocean, and we worked with Naval Oceanographic down in Stennis, Mississippi, and got a lot of data from them. I went down there several times to work with them. Then one of the universities in San Diego gave us a tremendous data set of the oceans in California. I mean, if you go to Monterey and look underneath the ocean, it's just shocking how much, you know, high quality image or terrain there is. USGS, you know, if we can't get anything better, we use the SRTM, which is 90 meter of the whole world. So that's the lowest quality that you'll find anywhere in the world. And then on top of that, you know, we're just constantly trying to get better and better information from whoever we can give it to. The United States is very unique. The United States makes a huge amount of data available for free to the public, and nobody else does that. You know, you can't go to France and say, I want, you know, imagery from France or terrain. I mean, it's all really closely held. But the U.S., I mean, it's really surprising how much data is available.